Just get us. Oh. Just get us started. All right. You all can hear me at home, yes?
Yes.
Okay, so here's our calendar. Today is Wednesday, the 23rd. Mod 8 is due today. You have a
You're not share screening.
well, then that's oops, forget something. Better?
Yes.
Okay. So the 23rd. So there's a discussion we have to do today called Growth 3. Okay. And next week you don't have one too, but there should be a quiz too next week too. Let me see. Oh, it doesn't show the quizzes that are due. Let's see. So quiz number, really, you're still not going to show me? So quiz number 7 is due today, along with the growth rate discussion. That's due on the 23rd. Next week, quiz 8 will be due. So I have a lot to do today because I really wanted to review for the midterm. So let's take a look at the midterm. Okay, so just looking at this schedule too. Today, the practice midterm exam was due on the 23rd. The midterm is due in 2 days. Did y'all take the practice midterm? I'll find out soon enough. Yes or no? No. Why not? Forgot, you have a test in 2 days, and it's a big test. It's not like a little test, big test. Let's take a look and see. Let's go to Alex and see what you did. I can figure out what to do with that here. Just be small. Be small. Okay. Let's take a look at the assignments that you were supposed to do. Okay, so quiz 7 is due till midnight tonight. That's not a big deal. But you will see the practice midterm I wanted done before class because I wanted to go over it. That's why it's a big deal. Because having it due after the midterm is not going to help you on the midterm. Let me see how many people took this test. Oh, a bunch of people took it. The grades weren't bad. Let's see what the item analysis says. This is good. I get to go over the item analysis. Ooh, oh, ouch. Okay, so let's. I think I'm going to go over them in the worst to first. Do you mind if I do it that way? It means they won't be in order. This one everyone missed. Find the interception from a graph of from the rational function. Find the intercepts. This is one of my favorite exam questions. It's for sure an exam question. Here, they give you a graph of a rational function, and they ask you, write the equation of the vertical asymptote, and then write the equation of the horizontal asymptote. So what do you write? Do you see the vertical asymptote? Does everyone see a dashed line here? Just write down that. Do you see this dashed line here? What's the equation of that line? And you could go to Desmos and check it. What gives you a line that looks like it's at, where is that line? Can anyone tell from looking at it? Can't make it any bigger. Okay, so there's a line there, right? And that labels this as the y-axis. So this is 1 to the left. And if you look in the next, it says -2. -2 is the next one over. So where might this line be? -1. Now, how do you describe a vertical line? What's the equation of a vertical line? You know how in Desmos is giving you an answer, it gives you a vertical line? Because it's x equals. Okay, if you type in x equals -1, you'll get a vertical line at -1. Okay, what about a horizontal? What about horizontal? What would be horizontal equation then? If x equals -1 is vertical, what's horizontal? What variable should I use? And then where would you see a vertical line or horizontal line? I see an X, and that dashed line is right on the X-axis. What's the Y value there? You can look at the Y values 8, 6, 4, 2, and then what? 0. Okay. X-intercepts. Where does it cross the X-axis? Look like it crosses it anywhere? No. So, do you see that there's no? This is the x-axis. There's a dashed line there, but the blue graph doesn't cross it once. Not once does it intercept that. It may be way at the ends, but no, probably not. Okay. Normally with this problem, they label things. Like if it's crossed there, you see a dot. There's no dot, so I would say none. What about y-intercepts? Do you see any y-intercepts? Crossing the y-axis. Here's the y-axis. There's the letter y. Does it cross this anywhere? What do you think? Is it crossing it anywhere? I think there's a y. I'm coming down. This is it. The blue line is not touching the y-axis. Is it touching it here? Here. There. Here. Here. Come on, anybody? It looks like there, -3. Yep. Good. Right. It's 3. And that's one of the choices. So find the domain and range of this function and write the answers in interval notation. Domain. Remember domain. Think about it as raining here. Let's just say suppose it's raining like this. If the rain hits roof, you're in your domain. So at -7, you're in the domain. At +7, you're in the domain. Is there any place where I can draw these arrows where I I will go straight through all the way to the bottom? How about right there? See that? Where is that? At what value? The vertical asymptote is there. Where is it? -1. Thank you. So what I want to say for the domain is that it's everything except -1. So to do that, I have to put -1 here and a -1 there. That omits, by not having a closed bracket, it omits -1. Want to understand that? What do I put on the other sides? Since it's everything on one side and everything to the other, and what values does it go to? -infinity and +infinity. Which one goes? Does it matter which one goes where? -infinity comes first. Then regular infinity comes last. Has to be smallest to biggest in interval notation. Okay. Now, how about the range? Range is the one where we shoot across. If we hit the graph, we're in the range. Did we hit the graph there? Yes, it's in the range. How about here? Hit the graph? Yes, in the range. In the range. In the range? No. At 0, it goes straight through. There's no x-intercept. It went straight through. How about over here in the range? Nope. Nope. So all of those big lines are not in the range. The short ones are. How do you describe all those y values from where to where? From where to where?
Negative infinity to 0,
It's negative infinity.
or is it is that -1?
No, it's negative infinity. It's 0. The -1 is for the vertical asymptote. The horizontal asymptote was at zeros. And you see how I put a parenthesis there because I'm not including 0. Okay. That's correct. Let's see if there's, let me pop another one in. Okay, so this one right here. There's a bunch of stuff here. This one's particularly cumbersome, but where are the vertical asymptotes? X equals what?
3,
4. And then you have to use the and. X equals -2. Okay, good, good. Horizontal asymptotes where here? Y equals 0 again. Okay, the domain and range. What's the domain? Anyone? I'm just doing this because it's easier for me. What am I? Remember, think about the rain. Am I getting rained on at the negative numbers? Over here at -6. Is there a roof over my head? Yes. How about negative infinity? Let's start with negative infinity. Negative infinity, sure. The graph goes all the way over there. Okay. How about here at -2, where there's a vertical asymptote? Will the rain get through that dashed line? Is there any roof over your head if you're standing at -2? There's no roof over your head, so it must not be part of the domain. So -2, and then you're excluding -2, so you put -2 there. And is there anything else we want to exclude? Because there's a vertical asymptote there. Where? What number? What number? Does it right there? 4. Okay, so that's the way of saying everything except -2 and 4. How about the range? Let me get my gun out here and start shooting. Okay. Am I hitting something here? Yes. I'm hitting something here. Yes. I'm hitting something here. Yes. Here. Yes. Here. How about at the horizontal asymptote? Am I hitting anything here? I am. Can't even get through there. So anywhere I shoot, I'm hitting something. So what's another way of saying that?
negative infinity to positive infinity.
Or all real numbers. Okay. Intercepts. X-intercepts. Do you see any X-intercepts? I see one. Where is it? 3. Do you see any Y-intercepts?
2,
2. Okay. No. There's an X-intercept there at 2. There's an X-intercept here at 6, -6. So there's an X-intercept at -6. Horizontal asymptote is Y equals what?
negative.
It's not -1. And the vertical asymptote is X equals 2. Everyone okay with that? Is there Y-intercept? Yes, it must be at 3. Okay, the domain is everything except for these, the domain and range will look like that. It'll be everything except 2 and everything except -1. Okay. I'm pretty sure this problem's on the test. Been on the test before. are you gonna get, you will get partial credit for it. But is there any part of this that you think you might, I just think this is a really good question about domain and range, inverted asymptotes and horizontal asymptote. Yes, CJ,
How many questions are on the midterm?
I don't know, 20, 25. No more than 25.
Okay,
Usually. If I make it like 10 or 15, like 15 is okay, but less than 15, people get lower scores. Because you miss a question or two and it starts chunking up your grade. So I'd rather have more questions worth less. 25 questions at 4 points a piece is 4 or 5 points a piece is nice. But this one right here has a lot of parts. Sometimes they're worth more. So they have more parts. I want out of here. I want to go into this one. Inferring the properties of a polynomial. I love this one. I love this problem. Have I not told you how much I love this problem? Did I not promise it on every single test? I should have, because it's going to be on every single test. So what's the holdup? Who's going to tell me? Over which intervals is the function decreasing? So just because there's a lot of parts, is that the problem why you don't do well on it?
yeah, I always get this one.
Why do you always get this one wrong? So easy. It's not easy, but it's got a lot of parts. Where is it decreasing? Where is this function decreasing? Negative infinity to -7. Where else? Negative.
Two.
That's -3 to 2. Okay, -3 to 2. Anywhere else? What 5 to infinity? See that? It's dropping here, it's dropping there, it's dropping there. Any questions on that? Where give the x values for where this function has a local maximum. So is this a maximum right here at -7? No. How about here at -3? -3 is how that would be, but okay, and what else? And 5. You'll notice that it was decreasing after those values. So when you see decreasing at -3 and 5, those are 2 numbers you saw in the previous problem. In fact, that's how I grade it. When I'm looking at them, I just look at the problem above it and see if those numbers match. Okay. What is the sign of the function's leading coefficient? It's going up on the left and down on the right.
Negative.
So it's negative. Okay. Which of the following, what's the, this is one of my favorites. What's the degree of this? How many faces do you see? So what's the possible degree? Not 4.
5, 7.
5. 7. Any others? 9. How about 3? Try another one. That's the same one. Okay. What's the leading coefficient here? I'm skipping all the way to the sign of the leading coefficient. It's positive. Why?
Both arrows are.
It's going up on both sides, like a smiley face, like a pumpkin smile. All right. What are the possible degrees of this? How many faces do you see? 6. So 6 is one answer. Are there any others? 8. Any others? 4? No. Good. Do I need to try any more of these? This should be a pretty easy question. There's no part credit for it. You either get it or you don't. Because even if these questions are worth 5 points each, there's 4 parts here. There isn't too much part credit I can give. Okay. Try another or let it go. Any more? No, I'm letting it go. But I'm totally not letting it go. You'll see this again and again. At least twice. Okay, 33. Graphing a piecewise function. Meh. You can do these on Desmos. But there's various flavors of piecewise functions here. When it says g of x equals a number, that's going to be horizontal line. That's like y equals -3. Except, so it says y equals -3 if x is not equal to 0. So I'll put a horizontal line at -3. But I have to exclude when x is equal to 0. So I have to exclude, I have to put an open circle when x is 0. So I have to put an open circle right there. Okay? So it's saying it's -3 everywhere except when if x is not equal to 0. If it's 4, if it's 3, any of those, it's always that. But there's one time when it isn't, and that's when x is 0. When x is 0, what is the function? 0, it's what? -2. So that's the point you're going to get 0, -2. That's what that graph should look like. Okay? That's one possible answer. Is that like a straight line and a hole somewhere, Alex? Oh, that's one of the things it does. Let's try another. This is another one where you have a step. Where you go step, 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 step. Okay? That's another definite possibility. 5 steps. Try another. Here's one with only 4 steps. Okay.
Is there a midterm review? Like, I know.
This is it.
I know it's already due, but is it like gonna be open, like if you want to practice more?
We'll talk about it later.
All right.
Okay, this is the same as the other one. This looks like a horizontal line where? Where's the horizontal line? At -3. I put a hole at 0, and I put a closed circle where? I go to where? 0, 4. Okay, next one. 5-stepper. 5-stepper. The one like we just did. I'm looking for one that has 3 on it. 2, 2, 2, 2. There's the 3. Okay, so this one is a segment. So when x is less than 1, thing is -1. So from here to there, that's what they mean by it's less than 1. I have to put an open circle there like that. So they mean everything, it's -1, it's like a horizontal line, but only this part. When x is equal to 1, it gives you 3. So when it's 1, function gives you 3. So I'll put a circle dot there. And then the other one is going to be equal to 0 here. Okay. So it's a horizontal line on one side, a horizontal line on the other, and then a point in the middle. Okay. Those are what these look like. We could ask Desmos for help, but this one right here is going to be a line going this way, a line going that way, and then or like a ray going this way, ray going that way, and a point. The point that's going to be is the point 0, 0. It's going to be when it's less than, it's going to be -2, so it's going to be like that. Oops. Then over here, it's going to be +1. Okay. This shows up on the midterm a lot. It's not my favorite question. It shows up a lot. Okay. And do you need to see more of that question, or are we good? I showed you all the different types. It's the 5-stepper, the 4-stepper, the 2, 3-stepper that's sort of 2 rays and a dot, and then there's the one line with a dot. So all the things that Alex is going to ask you anything else. Okay. A word problem. Okay, so I'm going to need Desmos for this, so let me pull Desmos up. Got me a nice clean Desmos. That over there. It's my problem. I'm gonna make it nice and big. All right. A certain forest covers so many square kilometers. Suppose that each year this area decreases by 9%. What will the area be after 9 years? I have to put that it didn't copy the numbers over. Okay, so what we're gonna do, we have the problem copied in here. Certain forest covers an area. 21 does it, and it decreases by 9%. How many be after how many years? Oh, got the number. 9 years. Okay, so I have 2,100. If it's decreasing by 9%, you guys ever do this? You ever get 25% off at a sale or 20% off? What's a good way to calculate that? What would you do?
I usually like get the whole number and then multiply it by the percent and then subtract it.
Okay, I'm gonna give you, no, but I'm gonna give you a shorter hint for that. I think, and that's what most people do, they take the 20%, multiply it by what you're paying and subtract it. Let me give you a one stepper instead of a two, but still two steps, just different. If you're getting 20% off, you're getting what percent on? 80%? So just multiply 80% times whatever you're buying, and that will tell you what the cost is, no subtraction. So in other words, if you're buying something that's $10 and it's 20% off, what you're telling me to do is take the $10, multiply it by the 20%, subtract that away, and you get $8. I'm saying take your 20%, subtract it from 100%, so you get 80%. What is 80% of $10? It's just $8. I know this worked totally awesome. I was at a store that was going out of business, and I heard the woman behind me tell her husband that this guy knows what's good. I think they were following me to find out what I was picking up. Because I could do, because they had, you know, they have like 70% off, 80% off, 90% off. So I wasn't multiplying, but I wasn't subtracting. I was doing for 90% off, you just multiply by 10, where you just chop off a number. If it was $11, chop off, so it'd be $1.10 or something. For 20%, you just multiply it by 2 and chop off a number. For 30%, you multiply it by 3 and chop, or not 30% off, 70% off. You multiply by, you count what's on, 30% on. So anyway, since this is 9% off, what percent is on? 91%. So we can write it as 0.91. If I multiply that by 0.1, that's how much I have after 1 year. And then after 9 years, it's going to be how much? Well, you're gonna multiply it again by 0.91. That's after 2 years. And then after 3 years, you're gonna multiply by 0.91 like that, right? So you could sit here all day and copy them. Actually, I can copy. Thank you, Desmos. I can just do copy, paste, paste. There's 9 of them. I could do it that way. Or I could just take this and raise it to the 9th power. Same answer. Okay? Does everyone understand that? Do you like the percent off? Did we talk about percent off? There's a formula for this. You could also use this formula. P equals Q times 1 plus R over N raised to the NT. That's, remember that formula, the compounded formula. This is not continuously, but they didn't say it was dropping continuously. They said it was dropping. There's an R in there too. Okay, so I know the starting amount is 2,100. I know the rate that it's decreasing by, it's decreasing by, so you have to put minus 0.09. And then the number of times, that's every year that happens. That's not an R, that's an N. So it's 1 times 9. And it's the same answer. Okay? All right, any questions on that? Is that the answer here? 899, because you have to round it. Do you want to try another one? These word problems, see if we got it. Oh. Okay, a principle of, can you remember these numbers? Because it doesn't seem to copy them all. There's 4,600, 47.57. Decimals. $4,600. 7.5. 7. Okay. So I'm going to use this same formula, P equals QE to the RT. P equals, now this is the other one. So the principal is 4,600. The rate is now, this is 7.5% interest. So how do I put that in? 7.5% interest, I put in how? Anyone? Let me just say, if I put in, what?
0.075.
It's 0.75, or I could put in 7.5 divided by 100. That's 7.5%. Okay, now how many times a year is it compounded? It's compounded annually. So how many times a year is that? Well, that's monthly.
So you would just put 7 years?
Remember, you put 1 in because that's how much it's compounded by 1 time per year. You put a 1 here, and then you put the 7 in for the time. That right there, that 1 is because it's compounded annually. And there's your answer, 7,632. Let's see, that's the answer. 7,632. Okay. Let's see if there's another one that's different. Yeah, these are all compounded once a year. So there's no monthly or anything in this. Ooh, this is a good one. Oh, this isn't, okay, so this isn't what I thought it was, but we'll do it anyway. 205 and 6. Okay, so we're starting with 205. A half-life is how long it takes to do what? What do you think it means? A half-life. Life is an amount of time. So if it's a half-life, could you imagine it's the amount of time you use in you're using up half your life? So if I said you're going to lose half your life in a half-life, like if it was 5 years, you'd lose half your life, that would be sad. You'd be dead soon, right? You'd think that. But here's the problem with half-life. It's half-life is how long it takes to get you're going to get cut in half. So you see that's 102. That's 1 half-life. After 1 half-life, the population, instead of being 205, is now 102. Okay, after another half-life, you're going to multiply it by what? Half again. Now that's 2 half-lives. After 6 half-lives, what are we going to get? Well, here's 4 half-lives. Here's 6 half-lives. So now it's 3.2. Okay. Does it ever get to 0? If your life keeps being cut in half, it's never going to get to 0 because it's going to keep cutting it in half. All right. Any questions on that? All right, that was a weird one. Oh, and the answer is just 3. The answer is anything. No. So they're either increasing or decreasing, but these are all compounded annually. More half-lives. I don't see any more half-lives, so I'm going to let this go. All right, next. That's a word problem. That was a final amount in a word problem. Those tend to be the easier word problems, but nobody loves word problems. And they tend to be, yeah, well, I wouldn't be surprised if there's word problems there. Okay. What? No, this is another one of my favorites. You guys are bombing all my favorites. Okay. This isn't my favorite, but it's a good one, and it tends to be on the test. For each function, state whether it's linear, quadratic, or exponential. Now, you could take the time to put this into Desmos. You could sit here, go into Desmos. You could create a table, and you could put those numbers in 3, 4, 5, 6, 7. Oops. And then you could put these numbers in, -9, -17, -25, -33, -41. And then you could take the time to look at it, say, what does that look like? Are those in a straight line? Do they look like they're in a straight line? They look like they're a straight line to me, but looking like a straight line doesn't mean it is a straight line. So the best thing you can do is figure out if x's are going up by 1, how much are the y's going up by? What's the difference between, I'll just take out your difference. What's the difference between -17 and -9? What did you have to do? Did you subtract 8 from it? It's not, let me type -8 in. Okay, what was the difference between how did you get from -17 to -25? What did you do? Did you subtract 8 again? And then did you subtract 8 to get to 33? And did you subtract 8 to get to 41? Okay, that's linear. You have the same number appearing every time? Linear. Okay. All right. How about the next one? Okay, I'm going to put this in Desmos too. It's another table plus a second table, x2. 5, 6, 7, 8, 9. Okay, fine. What about over here? 47. 31. How did you get from 4? How much? What's the difference between 47 and 31? You subtracted what? You know how much you subtracted? 15. Okay. For some reason, I can't get it to work yet. Did I subtract 16 for every one of these? That's 16. Okay. I had something. Okay. No. I'll make it bigger. Okay, minus 16. How about 31 to 18? What do you get there? Minus what? That's not 16. What is that? This 31 minus 18. Really? What is 31 minus 18? I'm not going to say it. I'm calculating it. What's the answer?
13.
Thank you. Minus 13. How about what is 18 minus 8? You can do that.
10.
Minus 10. Okay. How about 8 minus 1?
7.
So does that look like okay, so the data, I didn't get the data here. The data doesn't, okay, let me get this data on. Where's this data? Oh, there it is. What does that look like, those green dots? I don't know, it's really hard to say. Okay. But they're not dropping by the same amount, so it's not linear. If you want to know if it's quadratic, the way to do it is to create another column here. And subtract, do the subtract. What's the difference between minus 16 and minus 13? What's that? Yeah.
Question. You said we can use decimals on the test, right?
For everything.
When I did the honor block, I was like looking scared to get out the tab and go into decimal. Like, do you like get alerted when I like change the tab?
Sometimes it doesn't matter, I don't care. Some people try to open up, you should open up one of the Desmos links that I've given you. You try to go to Desmos without opening up one of my links, it might not let you, because I let you go to specific Desmos links, not to all Desmos links. So, okay, anyway, I add 3 to get minus 16. I add 3 again. I add 3 again. So that's a parabola. If you see the same amount changing in the next, so the first round it dropped by numbers weren't the same, so it's not linear. But if you do it the next with those numbers and you get the same number, that's a parabola. So that's a quadratic. Okay. Right. Let's do the last one. The last one is this one. Okay, and it is, again, don't have to use Desmos for this. 2, 3, 4, 5, 6. Okay. I got minus 96. I got minus 48. I got minus 24. I got minus 12. And I got minus 6. Okay. Okay, so let's just subtract them. What happens when you subtract 48 from 96? What do you get? That was 48. What about the next one? 24 from 48, that's 24. What about 12 from 24? That's 12. And then 6. Okay. So it's not linear. It's a quadratic. What's the difference between 48 and 24? 24. The difference here is 24. What's the difference between the next one? 12. What's the difference between the next one? 6. Okay, so it's not quadratic. So it's not linear, it's not quadratic. What does it have to be? Okay, so then there's exponential. For exponential, you have to have something like the number gets cut in half. Is that what's happening? So instead of doing arithmetic, look at what's is 48 half of 96? It is, it's 1/2. Okay, it's 24 half of 48? It is, it's 1/2. Okay, it's 12. What's 12? 12 is 1/2 of 24. What is 6? 1/2. So this makes this an exponential function, because to get from the one term to the next, you're multiplying by 1/2. It's multiplication. So that's what makes it exponential. Okay. So for these, it was linear, quadratic, exponential. Okay. It doesn't have to be that way. Like, for example, this one right here is probably quadratic. So here it dropped by 10, and then it dropped by 6, and then it dropped by 10, 6, and then 2. But 10 to 6 is 4, and 6 to 2 is 4. So that's how you'll know this is quadratic. Okay. This one is dropping by 19, then it's dropping by 16, then it's dropping by 13, 19, 16, 13. This is also quadratic. All right. This one here is dropping by 8, dropping by 8, dropping by 8, dropping by 8. That makes it linear. Okay, so Alex sometimes doesn't have linear, doesn't have quadratic, doesn't have exponential. Okay. All right, are we done with these? Do you need to say any more of them? I wouldn't say that's a guaranteed exam question, but it's up there. Okay, what happened with my problems? Okay, next one. Inverse function, linear and discrete. Okay. For this problem, there is one question that's harder than the rest. Everybody else is easier. Okay, so. So the the first one here is the hard one. So if I have g of x equals minus x plus 13 over 7, how do I find the inverse? Okay, so there's Alex giving me the function. Do you remember how I got the inverse, how I got Alex to graph the inverse? All I had to do was switch the x and the y. That's what an inverse is. Switch the x and switch the y. That green line right there is a graph of the inverse. You see how it looks kind of like a mirror image? Right. Now, how do I find the equation of that green line? Well, it's here. I just have to rearrange it. I could bring this 7 up. Make it like that. Oops, not there. Okay, someone say I pulled the 7 up. And then I can move the 13 over. See how the line just keeps saying the same? What happens if I take that negative to the other side and make this negative? And then this one must be positive. Okay, that's so it's 13 minus 7x. So when I go to the inverse thing here, it's going to be 13 minus 7x. Okay, that's the hardest one. The next one, g inverse of g. They undo each other. So what happens when you have something and somebody undoes it? What happens when you clean up the kitchen and your little brother comes and messes it up? What's he cancels out and it's a messy kitchen. Your parents come home and say, why is the kitchen so messy? Okay, so if you started with a sick kitchen, and you did your job and it was undone, then you get back what? Same sick kitchen. So what number is it? 6. That's it. So no thinking there, no writing. That's all the thinking you have to do is copy that number over again. Okay. Next one. H inverse of 5. Well, this is H. So it's going to take, let's say, -8 to -9. And it's going to take 1 to 5. And it's going to take 4 to 2. And it's going to take 5 to -4. They're asking for the inverse. If you give it 5, what will it take it back to? Okay, you're giving the inverse function is going back. It's not this way, it's the reverse. So which one has 5 as an output? 1, this one. So that's the answer for 1. 1 must have been put into the function to get 5. So to undo 5, it would go back to 1. Okay? That's correct. Okay, so let me just ask this question. The last one, what's the answer to the last one?
Negative.
It's just -1. No thinking. What about G inverse of 3? There's G. G takes 3 to -1, but they're not asking that. They're asking what goes backwards from 3. So which one goes backwards from 3? What do you get? 2. 2. Very good. The inverse, you have to solve this. So it would be like 11y plus 13. I'm just going to pull that 11 up. So it's going to be 11y. And then I'm going to add the 13. So I'll do plus 13. And then I can't leave it that way. It's a function of x. Change that to an x. Okay. All right. This is a nice question. It's a very high probability of being on the test. Okay. If you can't get, there's only one part of it that's hard though, right? The inverse one's pretty easy. The one where you're composing them, not super easy. The hardest thing is the one that said find the inverse. For that, you switch the x to the y and solve for the y. All right. Basic properties of logarithms. We went over these last time. What happens when you add logarithms? By the way, I'm just gonna do it on Desmos because what the heck? This could totally be done on Desmos without even thinking about it. Okay, so what is the log? How do I get the log base 2 in Desmos? I do what? Anyone remember? If I type 2, it looks like that. How do I get a subscript? Does anyone know?
I'm gonna go on the keyboard.
No, you don't have to. You can do shift minus. Does anyone know that? Shift minus usually gives you the underscore. Like there's the minus button, and then above it is the, if you shift it, you get the underscore. It's the underscore that gives you that. Okay, but you can go into the keyboard. But the shift minus is good. Plus log shift minus 2 5. Well, that's the answer. But what is it? Okay, so here's what you can do. If you really want to cheat, you can just say equals log shift underscore 2 of x. Okay. Now, what will Desmos do to the answer? It will give you the answer where it is. Let me get rid of these. The answer here is that x equals that number. What is that number? What's it look like to you? 45? Okay, but look at the problem. What is 9? If you're adding the logs, you're just adding the 9. You're multiplying 9 times 5 to be 45. Okay. So if I want to check it, I can just do this. Are they the same? They are. Okay. So one of the properties said to multiply those to get 45. What do you do when there's a subtraction there? What does that become? Do you remember? Divide. So you get 5/2, so you get something, log of something minus the log of 2, you get the log of 5/2. What must that something have been to be dividing it by 2 to get 5/2? 5. Okay. And this one right here, use that ladder property to bring the 2 up front. And so you get 3 squared, which is 9. But again, you could put this in decimals. Just put a little x in for the unknown. Okay. I generally find this to be a pretty easy question, and I generally find it on the test. Generally. And I find it on the test because I think it's an easy question. Is it an easy question? Okay. Because you can always do it this way. Always ask Desmos to do it for you. Because I'm thrilled if you get Desmos to do it. Thrilled. All right, we're getting to 58%. Let's see. For now, almost 2/3 of you got this. Okay. This is not my favorite exam question. It shows up once in a while. But all you have to do is talk about the end behavior. If you have a negative something to the 4th power, what does it look like in the ends? If it were positive to the 4th power, what would it look like? It would go up on both sides, but since it's negative, it's going down on both sides. So the way you have to read this is falls to the left and falls to the right. All right. How about minus x to the 5th? X to the 5th looks like what? It looks like a line, basically. But then what happens if you put a minus in front of it? Goes the other way. So it's rising to the left and falling to the right. Maybe? No. Rising to the left. Oh yeah, rising to the left and falling to the right. Yeah, sure. Now what about this one? First of all, what's the degree? It's hard to, it's not written out in that general form, it's factored form, but if you multiplied it all out, how many x's would you have first? You have a 3x, an x, and an x squared. That's x to the what power? 1, 2, 3, 4. 4th power. And if you multiplied it all out, the leading coefficient would be positive. So x to the 4th looks like what? How's it look?
Both going up.
Both going up. And positive would be both going up. And that's the answer. Okay. Honestly, just put it in Desmos. You have some time, type them into Desmos and look at the answers. Okay. You don't have to do it that way. I just did it. Okay. But get the answers. 58% is not great for that question. You can do better. I'm going to graph this, but I'm going to copy down all the instructions first. Over to the left. Log base 2 of x minus 1. Here's the decimals. Okay. Graph the logarithm of its function. Okay, so I have to graph this. I have to graph the function. So I'll do it. Just call h of x equals log base 2 of x minus 1. Okay, so that's the graph. It's going to ask for points. How do I get points from this graph? If I put the little wrenchy thing on and I click on the table, it can give me. Uh-oh, it looks like it's not defined for anything after, but 2 is. So let me just, when I get down to 2, I'm just going to hit enter. That's good. So there's a bunch of points there. I'd see 2, 0, 3, 1, and 5, 2. Those would all work. Okay. What else? But that's not what it says. This graph this function to do this plot 2 points on the to do this plot 2 points on the graph of the function. So I have to plot to do this plot 2 points on the graph of the function. So I plot. And I want 2 points. Does anyone remember what we had? It was 2. So 2, 0. Let me just see this. 2, 0, and 3, 1. So we'll graph those. 2, 0. Plot it. 3, 1. Plot it. So plot those points. Got it. Plot 2 points on the graph. Also draw the asymptote. Okay, what type of asymptote? Is it a horizontal or vertical asymptote? Is this a vertical or horizontal asymptote that this function has? And where is it? It's a log function. So logs have what type of asymptote? What do you think? It's a vertical. And where is it? Okay, it looks like it's at 1. That's what would make the log. You can't take the log of 0, so that's where the vertical asymptote is right there. And then once you do that, just click on this and it grabs it for you. You need 2 points in the vertical asymptote, and that's it. This is a pretty easy problem. I'm moving on. Oh, they would ask for the domain and range. I didn't finish it. So the domain and range for this, the domain is everything from the vertical asymptote in one direction to -1 to infinity, and the range here is everything. Remember, you can't see logs too easily. Remember when I was doing this thing with the arrows? It's like hit something, hit something. With logs, it hits something everywhere. You think that it's going straight through, but it's really hitting the graph. Okay, so it just hits the graph further away, but it does hit the graph everywhere. Okay. The rainy part is you're protected everywhere except for whatever makes the argument 0. That's where the vertical asymptote is. Okay. Any questions on that? Okay. Is this helpful?
Yeah.
Okay. Solving a rational inequality. This is pitiful. Why are you missing this? All right, 2/3 of you are getting it. For the 1/3 of you who miss it, and you know who you are. How do I solve this inequality? What do I do that makes life so easy? How about I just put it in Desmos? Got a problem with that? What can I put in Desmos? 15 divided by x minus 6 is greater than 5. Okay, tells me the answers right away. What is the answer? Between where and where?
4 to 9. Or 6 to 9.
6 to 9. Do I include 6? Do I include 9? The dashed line I definitely don't include. So I don't include 9. But what about 6? Do I include that? There's no line there at all. What's the problem with 6? If I put it in the denominator, what is 6 minus 6? No, what is 6 minus 6? 0. You can't divide by 0. So 6 is no good. Neither is 9. Why is 9 no good? 9 minus 6 is 15. I put the right thing in, right? Let's see if that's the answer. So it's everything from 6 to 9, not including 6 or 9. Here's the problem. Yep, that's it, 6 to 9. Why? So do you see how easy these are? I just typed that in. I typed that in. It's gonna give me two, there's gonna be two regions. Okay, if I type this in, x minus 2 minus x over 6. See, there's two regions, this region and that region. Okay? Do you include the number 2, yes or no?
Yeah.
Do you include the number 6? No. Okay, good. All right, is that enough from this assignment? Let's take a break. Just take a look and see. And that was the last of these. These 3/4 of you got, so I'm not going to go over these. Graphing an exponential function. I'm glad you got that. Graphing a logarithmic function. Yeah, you got that. Polynomial long division. Glad you got that. Solving an exponential equation by substitution in the quadratic formula. No. You got it, but you could just type that into Desmos. I'll tell you the answer. Okay. Let's break up into our groups and work on the next thing we have to, that's actually due today. I think last time we did evaluate and solve. Yes. Last time it was evaluate and solve for a logarithmic function. HA. What do you guys say? Alexis, are you here? Oh, where's your thing? Just want to see who's here. Alexis, you're saying that if a person is 70 inches, they should weigh, according to this regression, yeah. Don't write the word inches there, put it inside of the 70, if you're gonna write it at all. Akash, are you here? Let's see, Akash here. All right, well, Akash, he's trying to, I don't know what he's doing. He's telling me that an 80-inch person should weigh 330 pounds. But that's the same thing that you did, Alex. So I don't need it. In other words, what I need is a solve. He says, what if I want an exponential regression to equal 215 pounds? And I don't know what this crap is, but get rid of it. He says, what? For persons 215 pounds, how tall should they be? How tall is that? 6'2"? I think so. Okay, that's not so bad. All right. Tennis. Are you here? Yeah, so you want to say what you wrote there?
I'm black.
You could use it on your computer. Is that better? Starts according to. Can you see it? Why are you sitting in the back if you're blind?
According to the logarithmic graph at a height of 70 inches, that the weight is expected to increase to 100.
Okay, let me just say some things. According to the logarithmic regression, not the graph is a graph of a function, but it's the regression that you graph. At a height of 70 inches, the weight is expected to be 181 pounds. Don't use the word increase because that's a calculus term. You're not growing per se. You have no idea what's happening to a person who's 70 inches tall. They could be like me, shrinking. Because I'm getting old. So I'm getting short all the time. So I'm not feeling but I could be. Every time my bike blows and it's too small for me, I say, I'll shrink into this. My old age. And old people don't care what fashion is anyway. But even if it looks ugly, I'll still keep it. You must have a grandparent that does that. Do your grandparents wear nice clothes or no? Do they really? They must be young. I do.
My grandma, she's like 7.
She still dresses nice. God bless her. Well, I'm not, but I never did. That's a mistake people make about old people. They think that because they're old, they were born old. I was always out of fashion. So I'm not going to become old and become out of fashion because I'm old. I'm just going to slip right into what I already do. All right. Who is this? AJ, where's the rest of your group?
I have no idea.
Didn't they just do height and weight? They steal you?
Yeah, no, we're rolling.
Yeah. So this is a logarithmic regression. You have a vertical asymptote here, a little over 80 inches. So you can't be making no predictions about somebody who's like 82 inches. Even here at 80 inches, you say a person should be 332 pounds. That's a lot of.
Yeah.
A lot.
Should I fix that?
No, it's just what it says. That's why you say, according to this regression. That's why you say. All right. Genesis. She gives me links and everything. And David. What are you saying, David? Oh, wait. Is Joseph here? Joseph? Say what you wrote there. According to the, what are we doing here? Log regressions? It says log regression right there. So could you change it? Could you just say that? Go ahead, say it. According. Say it out loud. Come on. Log, according to the log regression. In 2027. 'There's 11 million people are expected to be wherever it is you're looking. Is it New Jersey? So just say that. How would you say that? 2027, the population in New Jersey is going to be 11 million? But that's according to the log regression. Okay. Good. Tatiana's not here. If she was, she would say in 2025, there's going to be what? So that's an evaluate. Did anyone do a solve? David, did you do a solve? You're solving for 11 million people. And when did that happen? When does the log regression say that will happen?
2026.
Like June.
Probably.
What?
Said probably. Middle of the year.
Middle of the year. Okay. Okay, next one. Momin, are you there? Can you hear me?
Yep.
And Octavia, what are you guys talking about? What's your topic? Pills sold? You're selling pills. And over the years? Billions? There in no way. And by the way, is it milligrams or billions of milligrams? I'm telling you right now that that number is way too low. Because I use 1 billion milligrams of pills just myself. I know. Anyway, what do you say here? I see a solve in 2022. There will be 5. At the end of 2022, there'll be 5. And then ending the other one. So let's see what you said here. Octavio said in 2023, there will be 5.0, whatever. Okay, is that an evaluator or solve? Octavio, is that an evaluator or solve you're doing there?
Evaluate.
It is. Justin, is Justin here? Is he doing an evaluator or solve? It's not here, but I can tell whether it's an evaluate or solve. What is it? Is that evaluate or solve? He typed in 2022 and got a number. What's that? It's evaluate. How about this one? Plugged in a number and got another number. What's that? Oh, Sebastian's also evaluating. Sebastian, why did you all evaluate? And you're the last one, Sebastian, so you should do a solve. The solve, it was given to you. There was a solve. Moment gave you a solve. All you have to do is say, I want, and by the way, I shouldn't use E, but whatever. The function evaluated at x equals 5 when x equals 2022.86. So that's what you're saying. You're saying, I want that. It's like I want f of x equals 5. X equals 2022.86. Okay, that's an evaluate. That is not evaluate, it's a solve. Okay. So Sebastian, you can post that so people know what a solve is. All right, so now let's move on to this week's one. That was last. There's 3. Is there some group missing? So you guys have a problem here. Because this particular problem, if you have a group that's too big, you may have to do something different. Okay. So here's what you have to do this week to finish this one, because it's pretty easy. All you have to do is, by the way, if I have time between now and Friday, I'm going to write an exam question for you, and it's probably going to be a Desmos link to a Desmos thing, which you have not seen before, and we'll probably ask you to do an evaluate and a solve. Probably because I know how to do that now on Alex. For my own question, and if I did have a question, it would definitely be an evaluate and a solve. Probably with no, it's going to be a question. Only reason it wouldn't show up is if I don't have time to do it. So my calculus class is sucking life out of me. All right. So let's talk about where am I? Okay, courses, your course. Let's talk about what you need to do today, right now, in lessons. In lessons. Okay, so look for growth rate. Okay, here's the thing about growth rate. It has nothing to do with growth rate. If you just open up your worksheet, so here's your, I'm going to go to sample worksheet. So this is a sample worksheet just like yours. And one of the things says exponential growth rate. When you open it up, it just says 100 times K. Right? Now, where did K come from? K came from the exponential regression. This was the exponential regression. K is the rate that you're plugging in there. Okay? So in exponential regression, it's solved for K. And in here it says K is minus 0.09877. In this week class, you open it up and it just says 100K is just minus 9.8% TK. So my growth rate, so the writer doesn't have to write anything except rate equals minus 9.8711%. That's all you have to write if you're the writer. One writer. Okay, then you have a speaker. They're going to say, according to the exponential regression, whatever your weight is increasing by or decreasing by whatever that percentage is. And that's it. That's 3 people. Does anyone have a group with more than 3 people in it? Yeah, so someone can actually read this out loud and record it. Because I haven't seen any of that. That's for 4 people. Do you have more than 4 people? if you have 5 people, then I don't know what you're gonna do. You know what you might do? Oh, you can go down a little further. You can turn this one on. And then you can have a different growth rate. Okay,
So what do I have to go to? Just turn on the line then?
oh, so if you're only gonna need this, then you should go back up to exponential and turn it on. Turn on the exponential growth rate. Turn on the exponential regression. There's the exponential regression. So if you just turn on the exponential regression and then give me the growth rate like this, you're fine. That's all you have to do. But if you have more people, what is the horizontal asymptote of an exponential function? Horizontal asymptote. Do you see it right here? Do you see how it's at 0? Everyone see that? That's a regular exponent. So here's what's neat. I told Desmos, which you can't possibly do on a graphing calculator, but I told Desmos to do it. See this right here? That's a regular exponential regression. But this says add something to it. Let it have a horizontal asymptote that's different. And when I do that, I get a different graph. You get this red graph. And look where the horizontal asymptote is. It's way down here at minus 2,491. Okay, which is a better regression, just out of curiosity. Do you see how look at the red graph. Let me look at the data for a second. So here's the data. See that data? Just see there's the red line is a different regression than the purple line, which is the purple line is the regular regression, exponential regression. The red line is a different regression. So if you have another person in your group, HA, if you have a different measure, turn this on, graph it, and let them say what the other rate is, minus 1.9. Say that the growth rate for the second exponential regression is minus 1.8%, as opposed to this one, which is minus 9%. Okay. So that's what you do if you have more people in your group. It's all in the same folder. All right, let's do it. We've got 10, 15 minutes. We're going to do it. Breakout rooms. Remember what breakout room you're in? We only have 4. We only have 3. Okay, so who's in Jake? Oh. Omen, Octavio, Sebastian, Taylor. Okay. Dennis, who is in your group? Is everybody here? Anyone on that list up there? Look, Taylor, senior group. Sebastian, January. What room are you usually in? Room 1? I'm going to put him in room 1. And it's one of you guys join him in so he can. What's your name? What is it?
Michael Samara.
You're one of the mics that I never see. Who? What group are you in? You were in 2, but I think 2 is gone. What number are you guys? 3? There are 3. And then Octavio is in 4. Taylor is, I think, also in 4. Sebastian is in 4. Are you guys in 4? Sebastian and Taylor. Okay. Do you want to join the people in 4 online? Or do you want to join one of these groups, but you have to do work? They may not have enough work for you. They're both kind of full. Who's AJ? Who's in your group besides?
Josh and Jimmy. I don't know where Jimmy's been, to be honest. I've not seen
It's
Jimmy.
not on this list.
I think it's under a different name. So
Sebas. That's Sebastian. There's nobody here in room 3. Do you remember what you guys were doing? You were the price of gas or something?
Yeah.
It's been a long time since I heard any discussion about gas. You want to do it or you want to join them?
I'll join.
AJ, will you take that mic and
Yeah, sure, bro.
see? Try to get you guys, I'm gonna try to find out. I'm gonna take attendance now.
So honored.
I'm taking attendance the hard way. AJ, why are you creeping up here?
Oh, all right. Then I was about to.
Look at all these COVID people right here in front of me going,
That's right.
it looks good.
Look, that's fine.
You have two of them, so you have two rates. The first one I see, you see me trying to get over there with my mouse and it's not working. You have the first one and the second one, so you have two rates, so maybe you have enough people to have. Give your data and stuff, give this graph, make sure they can see those two rates, and then have one person say the one rate. One write it, one write it, one say it, one write it, one say it, that's four people, and then if somebody wants to actually record themselves saying the rate. The growth rate, according to the exponential regression, the growth rate is like, that would sound very
Do I
cool.
just need to show them like the table and this?
No, no table. Why do you need the
Just
table?
this?
Just that.
Okay, because I turned on the exponential regression.
Yeah, but that's okay. You don't have, I don't see. It's right there.
So
I see. it. See, again, I'm trying to point about that. It's really sad. My life has really gone downhill. He's sitting here with his computer and I'm picking my mouse and I'm trying to go to his screen. Is that not sad? That's really sad, isn't it? It's it. Have you ever done that before? I mean, it's doable.
No, it's a non-screen, touchscreen. So I think that's either.
That's about the same, yes. I think it's because when I'm at home, I have three screens and the mouse after goes swirling and back and forth. But when I saw his screen here, I was thinking I could get them out of time. So it's not so bad. So yeah, so maybe it's cool and maybe I'm not just losing my mind as an old person. One time when I started teaching, mice were so new. This was like 2002, using Alex. And literally there was a woman sitting there trying to use Alex in the computer lab. She kept banging the mouse on the side of the keyboard. It's like, it won't go past the keyboard. I'm sure that was a long time ago. You gotta understand, that person is 22 years older now. That's how long I've been teaching. So if they were 18, they're 40 now. That's sad. That's not a, oh wow, that's a sad. I started teaching and those people are 40, but those aren't even the oldest. Oh. So this one guy, I got this email from a student asking me if I'm still teaching. I said,
$1,200.
Anyway, this is a student that I had when I was in college.
No,
A
you
guy
were trying to
who-
wait for it to go to gate
He's the
67
head
and
of
just-
surgery at some hospital in New Jersey. He's like Cooper, whatever. He's, that was like, wow. And you just wanted to know if I was still teaching, but then you could rub it in my face that I'm a huge failure and you're crazy. He didn't say that. He didn't say that, but the next thing he did, like a week later, he sent an email to all of his team. And there were all these doctors, there's like 12 doctors on his team or something, and he sent it to me.
The trains.
And I said, I think you don't need to include me on this mailing list. So anyway, that was so weird and sad. No, but that student was a long time. I mean, he's the head of surgery. He's in his 50s if he's a day. If he's a day, let me see, how old would he be? He was 18 in 1987.
That's long.
I was in college. I wasn't working. I was teaching as a graduate student, so I was student in 1987.
You were a student teaching students.
Yeah, I was a graduate student.
This is.
Yeah, it was weird. The first calculus class I taught at Rutgers was a night class, and back then night class was very serious. And they're all old people, and I'm like 20, and they're coming in, and there's a woman with her knitting, and there's a guy in a suit, and a bunch of people had cups of coffee and stuff. And here I am, like I'm like, wow, these are real adults, and I am not. I am unworthy to teach all these adults, but no, it's a good class. So weird. I was your age. What's your age?
19.
I was a little,
I would be so nervous.
but not much. I was 20. I was 20 then. I wasn't even 21. Yeah.
Be
So,
so nervous.
yes, I was. Anyway, huge failure that I am in life. This is all recorded on YouTube. Thank you, YouTube, for showing the future when archaeologists are watching old YouTube videos. They watch this one. You just don't think you're gonna get old. That's the problem. Sebastian and Taylor, you guys know what group you're in? Was Justin here? Justin wasn't here, right? Joseph is here. Michael Charleston is not here. Sebastian is here. Emilian is not here. Taylor is here. Octavio, Tatiana. Tatiana's not here. Jake was here. Didn't we see,
They put me at.
did I? Oh. I said you weren't here, and then I clicked it. Jake is here. What about this Chris? Was he here? I thought I saw his name earlier, but he's not here now, so. No, David is here. Genesis is here. Akash, not here. Dennis. Jimmy, why these people? Alexis is here. Moment is here. AJ is here. Chapter is not here. Michael T is here. 12 people. 2, 4, 6, 8, 10, 12, 14. Oh. I might scoot somebody over. Very hard to get this thing to give me a report. There we go, record.
You should think, next, did you post that? That's the only word I get.
Justin's been here quite a bit. Joseph's never missed a class.
Yeah, I'm never missed a time, so.
Sebastian missed one class. Emiliano's missed so many classes. Taylor. Taylor's remote, but hasn't missed any classes. Tatiana's never missed a class. Jake's not missed a class. David's always been here. Genesis always been here. Missing one of these classes is literally missing a week of class, which is like missing 2 classes. Back in the old days, I'd withdraw you. Now I just
Hasn't showed up at all.
who?
Who's the person above it just hasn't showed up?
Aisha, I don't even know what Aisha Walker looks like. Never shown up. Alejandro, I remember seeing him in some of my video I recorded, you guys.
Oh, I think you dropped the class.
I wish you would. But if you don't officially drop it, you stay on the roster forever. And the last day to withdraw is next week, right after. The reason why your midterm is now is so that you can withdraw if you want to. I think it's Friday.
This Friday?
The midterm is the day after tomorrow.
Oh, no, I thought withdrawal date.
Oh, it's not Saturday, it's next Tuesday.
Next Tuesday, okay.
I don't think anyone should, Richard, personally, it's pre-calculus. Don't try to. Okay, if you work hard, you can still pass this class. Even sight unseen of what you're gonna do on this midterm. I can tell you that I reward hard work. And the way that you're gonna get hard work done is if you don't finish this course on time and you still have a few weeks left to your Alex, I might let you take the final again later. And I might do that because it's Christmas. And not because I'm generous, but because your winter break means less work for you. Might not all your other classes end and stuff. You might actually spend time doing work in this class. In the summer, not a chance. I'd never give anyone extension in summer because it's already bad enough to have to work in April on a nice day. You know, today was a nice day. Can you imagine after a cold winter, and then you think you're going to spend that beautiful summer, spring days working on your pre-calculus? Ain't going to happen. But for Christmas, it'll be cold and miserable. And if you're anything like me, you hate Christmas. Humbug. Anyway, I think you could do it. So I would give you an extension to do it only because people have done it. But in the spring, they never do it. They ask me for all these exceptions and then the next day comes and I never see them again. So you can all pass. You should not withdraw. If you fail, failing pre-calculus is.
Hey, Professor, I have a question for you.
Yes, sir.
Do you know what I can do? So the same problem that happened with the test one doesn't happen with the midterm, like the problem with the honor lock thing.
Contact honor lock if it starts to happen, and take the test early on Friday, so that you can contact honor lock. Honor lock people are all over the world, so they'll answer your question anytime, night or day. But if you have a problem with honor lock, you click on the little chat thing on the bottom and say, I can't get this to work, and make them fix it for you. Do not, you can contact me, but there's not much I can do. Half the time you tell me you can't do something, I can't do anything about it.
Okay. All right.
I'm pretty tech savvy, but it doesn't mean I can do anything about it. So.
Okay.
But they can tell you if it's your device or if it's something I did. Sometimes it's something I do, and then you contact me and you say, Honorlog said you didn't open this test. And then I have to open it. Okay?
Okay. All right. I'll just
But anyway,
text them then.
Yeah. Okay.
Yeah. Last time the problem wasn't honor log. It was that I couldn't log into my Alex account for some reason.
Oh, well, I can check that.
Yeah, I couldn't because the link.
Oh,
the link that was on honor log. It was taking me to Alex, but every time I log into my Alex account, it was asking me for the code that I purchased, right? So every time I put the purchase into Alex, it told me that the code was already in use.
yeah, so let me just tell you right now, because I can tell you this. I can tell everybody this. Anybody who's still in this course on Alex,
Okay.
I could just sit here and click all day. Why don't you answer? Why not? This is another one of those things I don't like as an old person. I click, I get nothing. Okay. This is your class. Does anybody?
Okay.
So Alex should expire. So you see, I see this Alejandro guy, his license expires like now. 10/23. When is that? Like today.
Yeah, I think it's today.
Yeah, so
Yeah, today.
Akash, his expires. I don't know why he bought the shorter license, but it's going to expire like a week or two before the final. So he's got to take the final early, which means he's going to have to ask me to take the final early, or else he's going to have to spend $40 to get another month of Alex.
Yeah, I got the one that expires like next year, I think.
Which one are you? Which one are you?
Taylor.
Yeah, you don't expire until the middle of January or the end of January. So you're fine. You shouldn't have any problems. So when you log on, so the way you do it is you go into honor lock first. So you go.
Okay.
Everyone knows this. Do I have to remind it? And no one else had this problem? You go to lessons and you should go into honor lock. It'll be right up at the top and say test 1 honor lock. This one says test 1 honor lock.
Okay.
Right. Going to say midterm honor lock now. Honor lock button for midterm. Okay. It's the same honor lock, I just changed the name.
That's key.
Okay. So you click on that and you do your stuff.
Yeah,
Yeah.
like the
But once you do that, you're in honor lock. It's not it. Then it's not Alex anymore.
I know, yeah.
Honor lock problem. So click on that. Go into honor lock. Then after honor lock, when it's ready, it'll say now go open up your test. And then you
Gotcha.
all know how to open up the test. It works, I guess, because it worked. There was a time when it didn't
Okay.
work. I don't know why. Okay.
Can I try it right now or not?
You can't. You can try honor lock, but there's no test. No, there's no test. There's no test open now.
Okay.
It's closed.
All right. Yeah, I'll give it a try.
And I can't open up honor lock without opening up the test. So it won't open up until tomorrow at midnight. It's tomorrow, Thursday?
Yeah, tomorrow Thursday.
Tomorrow midnight. You can check it
Okay.
tomorrow. And unless you start, and if you go through the whole thing and you say, I don't want to do it now, you want to do it later on Friday, you can bail. Just can't, don't start the test.
Oh, we only
start
get
with that.
one try?
Get one shot at the test.
Okay. So I'll try to like do it tomorrow, like at midnight, and then if he doesn't let me, I'm just gonna like contact the honor lock support, or I'll just text you then.
Fine. Okay.
All right, sounds good.
Okay, so now everybody else, so we're running out of time. But did you all get your rates up? There too, so you have the midterm. Let me just go over the schedule again. You have, let's do, now that we're done, the class is over, basically, don't leave though, because I still have stuff to do. You have a test the day after tomorrow. It's a very serious test. Take it seriously. I gave you all that advice on what food not to eat and everything. Did I? Oh, okay. Well, let me give you some advice. This is a serious test. It's like taking a driver's test or taking something, but you should prepare for it. And when you prepare for it, don't just like wake up in the morning with your hair all messed up and say, "Hey, take that pre-calculus test." Don't do that. Prepare for this test. Get yourself like it's a race or a competition or something. The way you prepare for tests, there's a few things you can do. One of the things is I like to make sure that I've eaten and I've had some drink, but not a lot of drink, but I stay away from these things. Stay away from coffee, tea, soda, melon. These things all make you have to pee. And you don't want to have to pee during a test. So,
And how many questions are on the test?
there are 20, 25, something like that. Depends.
25?
In the 20 to 25 range. Could be as few as 15, never less than 15. Anyway, I'm closing the groups because we're almost done. Try to eat, don't eat watery foods that make you have to pee. The other thing that I don't, because honestly, I tell you stories, if you have to pee, you don't know you have to pee. So you're sitting there thinking that you're able to take the test and you're not. And if you're one of those people who gets up, leaves the test and takes and pees right away, your test suffered. It already suffered because you had to pee before you knew you had to get up and pee. So your grades go down. This is my theory anyway. It's called Professor Porter's pee theory. You can read about it. No, you can't read about it, but I'm told that it's on all my videos. Try not to have to pee during the test. Number 2, don't mess with your mind with artificial ingredients. And the 2 worst artificial ingredients are artificial sweeteners and artificial salts. You all know what artificial sweeteners are, right? I don't have to tell you, like aspartame or whatever it is, sweet and low. Stay away from fake sugars because your brain eats sugar. And if you tell it with some fake thing that says, oh, I've eaten sugar, and then you don't deliver, your brain's going to get pissed. And guess what's going to happen to your math test? It's going to say, you promised me sugar, and I don't have it. No math test for you. So don't mess with your brain. The other thing is the brain acknowledges there's only one part of the body that's more important than the brain. And what is that? The brain knows everything. What part of the body is more important than the brain? The heart. And the heart is a muscle. And you know what muscles eat? They are protein, but they eat salt. When you sweat, what comes out? Sodium. And so it's a sodium potassium pump. Your muscles do this. And your heart knows this, and your heart needs to have exactly the right amount of salt. And you know who regulates that? The brain. You eat artificial salt, you think, then your brain is going to be pissed the same way it's going to be pissed with the artificial sugar. And what is artificial salt? Does anyone know what it is? Salt is sodium, right? Have you ever heard of MSG? Do you know what that means? It means monosodium glutamate. It means a big fat lie. It's a sodium, but there's just one of the mono means one, monosodium glutamate. And there's this glutamic acid thing that the brain knows about. And it thinks you've eaten a lot of salt and you haven't. And what happens to your body when you lie to it that way is it freaks out, your brain freaks out. And sometimes people get like restless leg syndrome and stuff. Like MSG can really mess up migraines people get from eating MSG. So what is MSG in? Everyone's like, oh, Chinese food. Yeah. Chinese, it's not in all Chinese food. It's soy sauce. MSG is soy sauce. It's a natural derivative of soy. The glutamate is the protein in the soy. So anyway, so where is soy sauce? In a lot of Chinese food, but not all of it. But you know what else they put MSG in? Soda. You freaking drink that soda, and you know what they call it when they put, because it's natural, they call it natural flavor. So anything that says natural flavor, do not drink or eat, because that's going to be messing with your salt. Eat something with real salt in it. I'm not telling you what to eat, like not to eat. Just eat sugar or salt. These things are okay. Your brain is like, okay, we have a lot of salt, we have a lot of sugar, whatever. Just don't mess with your brain before a test. And don't eat too much salt, because then you drink water. And then when you drink the water, you're going to pee. And that's going to mess with your brain again. So I'm just saying, this has nothing to do with what to study. But I'm just trying to tell you that there's more to it. Athletes know this all the time. They spend a lot of time. He's smiling because you know that athletes do this. They prepare for, they take the creatine or whatever. They do all their stuff like it's a ritual so that they can perform. You have to do that for a test. It's a performance. And it doesn't matter whether you know, like you think it's all about, I'm going to know calculus. It's like, nah, people perform better if they prepare for stuff. You will get a better grade. And that is okay. I would love for you to get a good grade because you prepared and because you thought about this ahead of time. And then when it comes to like what to study and stuff, study the stuff you get wrong, because that's the stuff you're going to make a mistake on again. Other than that, I mean, and don't, here's some more stuff. Don't look at stuff that I didn't go over or I said was unimportant. Don't even waste your time on it, because maybe it'll show up. It probably won't show up that much or at all. Make sure you know the stuff that I keep saying. Every time you heard me say, I love this question. This is a definite question. Why don't you look over those again? Okay. And don't spend too much time on that. I mean, tests, you got to move along on tests. So you don't want to waste all your time on a test. Do the easy ones first. If it's hard, come back to it. Okay. Yes.
Can you open the practice midterm until Thursday?
Oh, so what did you want?
Just to practice midterm so we can like practice.
Let me, so somebody had a question though about this. What to do if you screwed up? Okay, so if you didn't take one of the quizzes, I can't open up the quizzes. I can open up the practice. For you, I'll do this. These quizzes, I can't open them up again. Bad things happen when I try to mess with them. But that's why I have these things here. Review test 1, review midterm. These are all the quiz questions If you have any questions and you want to see them again, this is where you see them. Here and there, these two assignments will have all the quiz questions. Remember that quiz 8 is not on the test. And while it says it's due next week, it won't be due next week. That I will give you an extension for also. That quiz 8 is ambitious for me. In my other class, my calculus class, I make quiz 8 due a week later. Okay, so you might have to do 8 and 9, or I may double up. I may push 13, 12 and 13. Sometimes I do together because they're not hard. Okay, so that opens up, but you want this, you want to take the practice midterm. That's what you want. And I wanted it done by today and you didn't take it by today. Fine, I'll open it up again, but can I ask you a question? Did anyone take it and want to take it again?
Which one?
Practice midterm. All right, so let me go into the long edit of practice midterm and say, students choose when to start this. What date do you want it by? I need it done by Friday, so I'm going to end it tomorrow night. Can I do that? Yeah, I don't want you trying. I don't want you to worry about the practice while the actual one is on the books. So you have till tomorrow. What?
11:59.
Oh, sure.
Just so I can.
No, please. That was a good one. I take that. All right, and then you want to take it more than once? Assignment has already says 3 attempts, but they're full retakes. Wah ha 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 ha. Okay, that means you have to take the whole thing from beginning to end. It's not like the quizzes are where you can go back and do the ones you missed. You got to do the whole thing. Because after all, let me just say this one more time about these practice tests. They're opportunities for what I just do. I just gave you some advice on eating and stuff. I'm giving you advice. Practice the practice test like it was the real test. Okay, another thing that what helped me in college the most is I was on the chess team in high school. And you say, so? When I was on the chess team, I could sit there and stare. I was known for this. People feared me. So I could sit there and stare at a chessboard and not move for like 20 minutes. No ADHD with me. I could just sit there like this the whole time and stare and stare and stare and just make people crazy. Anyway, that helped me take math tests and any test where you have to sit there and concentrate. Take these practices as an opportunity to concentrate. Like you have to build those skills. Concentration skills are not, they're not free. You have to work at them. So if you have any ADHD at all, just practice on these because they're not pressured. They're just practice. So just take it like it's just sit there the whole time and see if you can keep people from bothering you. Okay. By the way, I watch those honor lock videos, all of them. Not every minute of them, but anytime you're flagged, and I watch all the room scans, all of them from beginning to end. And it's so embarrassing. Yeah, you don't think I do, but I do. And I make little notes to myself I make notes about you. Like, oh my God, could they please have less children in the room at the time when they take the test? It's really annoying when people are screaming in the background. Really sad. Or, you scan your room and it's filthy.
Wait, you can hear us?
What?
You hear us like when
Oh, yeah.
oh.
And I have to hear you. If I don't hear you, you have to take the test again. So make sure that the audio works because people could just cheat, tell you the answers. I've had that too, where students literally stand out of the view of the camera and just talk and I can hear them. Or they turn their audio off and I catch them later on. I see reflections of them or I see somebody come on the screen. Look, I don't want to catch anybody cheating. So if you're good enough at it that I don't catch you, then I'm happy. But if I catch you cheating, it makes me sad. So I know the world is hard and I know you've got to, whatever, you got to do what you got to do. But if you work in this class, you should be able to get something. So the questions are the same questions. I mean, I keep the questions pretty much to Alex. The questions you see, I keep telling you what to do. So look at them, study them. take the opportunity to try to do the best you can. But yeah, I hear the honor lock. I don't look, I don't care. My house is filthy. I have no right to say anybody, you have a messy room. But some people's rooms are really messy. Like, and they make me say, oh wow, I don't feel so bad now. I never say to anybody your room is filthy, but I will say mine doesn't look so bad. But some people, so I see where you take it. I don't want to see, and so I don't have to, you don't have to take it in. You could take it in the library, you can take it someplace else if you don't like it. So there are people who think that what I'm looking at is too invasive. And I'm like, well, the problem is if I don't see this, you can't take online tests. So this is a hybrid class, so it's technically online, so you have to take the online tests. That's why we only meet once a week. But so the advantages are that you get to be at home in your pajamas. By the way, you take it in bed. I see that. That's another note I make. Why are you taking the test in bed? And I may or may not say something to you about it, but it's technically honor lock says you shouldn't do it. And if they come on, they'll say you can't take the test. And I literally see people pick up their computers. Like that's what I see. They pick it up and they move to a desk or a table or something because honor lock made them. Honor lock doesn't always tell you anything. So don't assume that because honor lock didn't catch you this time, that they approve. They're a bunch of people all around the world, and it's all run by computers, and they do what they do. And what they do is if you scan the room, like some people just scan the room like this, they go, eh. And of course I see that. And sometimes honor lock doesn't flag it. Oh, somebody did the other day. I never saw this before. It's very interesting. Don't try it because I see it. Flicked his lights on and off. And so it made it look like he was moving. Like honor lock was fooled by that. Honor lock was, oh, he must be scanning the room. And I was like, he's not scanning the room, just turn the lights on and off. And so I, of course, wrote something about it. I comment on it and say, don't do that again. That's why you had the first test, but you guys aren't going to do that, are you? But
Sorry to try that.
try it with some other professor, don't try it with me. But he got away from scanning by flicking the lights on and off, but I saw it. And anyway, I watched all of it, but I watch all the room scans and I only look at the videos for the questions you get wrong mostly, or the questions that you're flagged. If honor lock flags you for anything, I look at it. But again, they don't necessarily come in, but when they come in, they can be very annoying. And please don't curse at them. If you curse at them, like you just think they're just some automated thing, though those are actual people around the world who come in and they text you. Now, they're texting you half-assedly. Like there must be 100 people that they're handling at a time. So they get flags all over the world, like, Tatiana didn't do a room scan. So the person will come on and say, you didn't do your room scan, you got to see your room scan again. And then they go to the next person, didn't do your room scan. Like they just stretch these people thin, I'm sure. But anyway, but then if you curse at them and they hear it, they immediately flag you with a violation, and then they write it down as like you have problems violation, and then they send that to the dean. And then the dean may or may not ask me, well, what about Tatiana? Do we have to meet with her? Because I get those too. I get emails from students who cursed at the thing, thinking it was just a machine, but it was actually a person. So don't curse at the machine. Whatever you do, don't curse at honor lock. And you can say hi to me. People do sometimes. They know I'm there. They say, hi, Professor Porter. I am not getting this at all, or this is easy, or whatever. If you talk, sometimes I hear you. If you're doing well, I don't hear you. I only watch videos where there's problems. And for your own good, I watch the videos you get wrong. I will sometimes look at the work that you've done. Now I don't take any paper for this, If you do any work, you're allowed Desmos, save the Desmos, and there's a question at the end. So that's why it might say there's 26 questions or whatever, but there's only 25. The last question will be like, give me the link to your Desmos. And that way you have the work attached to the test. So you don't have to send it to me later. You just hit you know how to do it with the Desmos. You click with a little arrow, you get the link, and you just paste it right into the text. And then it's there. Then when you want to look at it, you have, but I only look at that if you're arguing a grade with me, but it's good to have it there. Okay, I will accept it that way. I won't accept it by email. I mean, you can send it to me and I'll say, that's nice. But I won't give you part credit for it or anything. Have to come with the test. You can, okay? All right, you guys, good luck. Oh, somebody hanging.
Right, this one, right, the 2 point, yeah, okay.
Take care, have a good one. Bye-bye. Okay. Anybody?
Hello.
Yes,
Yeah, I was wondering if we would have a like a formula sheet or
I think so, yeah.
okay, so you asked a good question. Why didn't you ask that earlier when the other people are here? Is there a formula sheet or no? Can I ask, has anyone seen a formula sheet? There is a formula sheet for sure.
And we can use it on the test?
There is, but hold on. Oh, where is that formula sheet? It's somewhere. Where would you go? You go into Honorlock first and it gives you instructions. Then you go to Alex. Where did I see it? Did you see it on the,
On the practice, no.
not on practice, on the actual test, the test one? Did you see a formula sheet?
Yeah, I did.
Where did you see that formula sheet?
Popped up. Like it just gave us an option to click on it if we wanted to use it.
Then it must be,
Like
I
attached.
don't think it's Alex. I think it's Honorlock. Let's see, but I know Honorlock allows it. But I can't go past here without screwing something up. So hold on. Loop. Okay. Okay, Desmos calculator. Formulas, 147 line instructions. So there's a formula thing. I don't know if this is the final one. This is final formulas. These are the, because you took the test, this is for test one. For test one, you were taking a comprehensive for the whole course because it was a knowledge check. So I give you the formulas for the entire course. But for the midterm, there's one that's just midterms. Let me just show you this one. This was all of them. So this is the formula sheet that you get for the entire course that has a lot of trig in it. But we only use this box up here. We don't need any of this. This is all coming. But that's all that we use, which is the compound interest formula, the exponential growth formula. We don't even use that box. And these are the properties of logs. And this is the inverse properties of logs. So anyway, that's all that I have on this formula sheet. Let me see if there's another point. Did I answer your question, sort of, Taylor?
yeah.
Are there any other formulas that do we need formulas and stuff? I feel like we do. In this class? Okay, midterm formula sheet, maybe. Yeah, the midterm formula sheet is just less of the trig stuff. Because, yeah, there's no, as far as I can see, that's all there is. 146 formula sheet. That's another formula sheet. This is all trig. There's some interest rate formulas stuff. But anyway, if you need a formula, let me know.
Okay.
These formulas, I don't think you need any of this. You don't need none of this for this test. Maybe interest equals principal rate times time, but even that, no, I don't think so. Okay.
Okay. Yep.
But yeah. All right. So yeah, but it's on Honorlock. But Honorlock will let you have a formula sheet. Look in the instructions, maybe. There's a link in the instructions on Honorlock.
Yeah.
And it's just a link, and you click on it and it takes you to you're allowed to open it. And if Honorlock says you can't open it, then you text Honorlock and say, I need my Desmos formula sheet. And then, or my formula sheet. My calculus class, the formula sheet is a Desmos worksheet, but yours, I don't think it's. Maybe someday, if I keep working long enough. Do it. Okay. Any other questions at home?
Nope. I guess that's it. But Yeah.
Bye, Tatiana, bye. Genesis,
Alright.
David. So long.
So Professor, the